Yeah, hello everyone. I see everyone starting to pop in here. So thank you for joining our EDX webinar on aviation communications in SignalPro. I was just given a few moments here to let everyone join in. As usual, we do have the question and answer panel as part of Zoom at the bottom there. So at any point, you can submit specific questions, and if it makes sense, we can call them out in the moment or answer them directly to you. But either way, make sure you use that panel if you have any questions throughout the webinar. With that, I will hand it over to Brian Jones, who will walk us through the use cases of aviation communications.
Hello, everybody. Thanks for joining. Hopefully you can see my screen and my slides here. As usual, I'm going to try and keep it to a minimum on the slides and jump over into the software frequently to sort of show you how we would go about some of these things in Signal Pro and show you a few, simplified use cases that you could build on in your own projects. Um, like Rory said, please do use the question feature if any questions come up while we're going through this. Or if you'd like to get more in depth and talk about a specific project, a specific use case that you have, please do feel free to reach out to us either through the support portal or through your sales account manager. We'd love to talk to you about any current aviation projects that you do have, or anything that's upcoming that you'd like to get a jump on, making sure you're getting the best making the best use of Signal Pro's features for this. Signal Pro has been in aviation communications for quite a long time. I've been with EDX myself for 20 years now, and one of my first training sessions was with the U.S. Navy, looking at aviation comms for telemetry on test aircraft. So there's a lot of different potential use cases that are not just the standard ground to air communications for position and voice that we're sort of used to thinking about. Um, but those are the main things we're going to talk about today. And really, what I want to show you are how the features and the architecture in Signal Pro will easily support really any different uh, ground to air or ground, or rather air to ground type of communications project, regardless of the technology or what have you. So looking first, let's talk about a few different really common bands that are in use. And the first one is the automatic dependent surveillance broadcast mode, or ADSB. And one of the reasons I want to talk about this is this is the broadcast mode from the aircraft to the ground stations, reporting their location to ground stations as they come into the air traffic control pattern for a given airspace. Um, and this operates at 1090 megahertz and 978 megahertz. And obviously, with these higher frequency bands, this can be very line of sight dependent, meaning that obviously, if you are back behind a mountain range from the system you're trying to communicate with, that's going to be a no-go. And so this is mostly a line of sight dependent technology, and therefore the studies are going to be more relevant the lower you get in altitude. Um, and there's a question here we'll come back to about what we call downlink versus uplink studies in Signal Pro. And maybe I'll sort of lay the groundwork for that now. In my example here, these are not ADSB sites. These are actually way down at 118 megahertz. Um, but in the example that I've got here, I have got my terrestrial stations, my ground stations modeled as the base stations. And for either my area studies, whether I'm going to do a heat map of coverage or whether I'm going to do a route-based study here, the mobile remote unit is what's representing my aircraft. And so in this case, I've created a few different mobile remote units at different elevations above mean sea level. So this is my 3,000 meters AMSL. This is my 5,000 meters AMSL. Why do I have to be so high? That's because we're looking at Denver right here. Um, and in the case of an area study, then we would typically we would plot or create different mobile remote units at different flight levels. And then when we set up an area study, we can choose which mobile remote units we want to run that area study with, and it'll give us all three of those layers. This is a somewhat new feature in SignalPro, the ability to run a study for multiple different mobile remotes that you've set up. And this is really useful for all kinds of different use cases, not just aviation. But so most often, if we're looking at received power to the aircraft from those terrestrial base stations, those would be, in this case, this is my received power at remote. And if we were going to do what we would often consider an uplink study, the received power at best base from remote, um, I ran into this terminology stumbling point a few years back, and so I always want to clarify. In the land terrestrial land mobile, we'll usually talk about downlink versus uplink signals, and talking back to the base station is our uplink, whereas talking out to the mobile is our downlink. Sometimes folks will call this talk in and talk out in the public safety world as well. And that possibly is a better descriptor because when we're talking about ground to air comms, what you might traditionally think of as a downlink study or received power at remote, well, that's from the ground up to the aircraft. And so, depending on whether your feet are more sort of in the land mobile communication space or you're more coming from an aviation space, it's really easy to get up and down confused. So I encourage you to solidify that terminology with your own team. Um, but so the received power that we're looking at here is up to the aircraft, which is my mobile remote unit from my terrestrial stations that I've set here. There are other ways that you can set this up that we'll kind of come back to. Um, but let's jump on to look at this other technology here, the ACARS system, which is Aircraft Communications Addressing and Reporting System. Um, this is both voice communication and the digital data that gets encoded periodically and automatically sent. That the really key thing about this is that it's down at a VHF, various different VHF bands, and uses a really reliable MSK modulation, which is similar to QPSK, and if you're from the broadband space. And so this is potentially a more non-line of sight technology, and sometimes will be used in sort of backup scenario planning or emergency planning type of situations. This is also the radio that if you were to throw a mobile radio in a truck and go out to a mountaintop to try and talk to aircraft from a distant location, this is the kind of radio um, that you could potentially use, or these are the bands that we would be looking at. Um, One really important aspect of this is how we set up the propagation model, either for ACARS or the ADSB. Um, planning for a typical like a digital mobile radio system, a terrestrial system, um, you might oftentimes have the add clutter loss option turned on here. What part of what we're seeing today is a greatest hits of possible mistakes that you can make while doing aviation. And my land use, land cover data, if I want to include that in the calculation, maybe because I have especially tall trees sitting along terrain ridges, etc., and I want to make sure I'm being extra conservative with all that stuff, um, I can switch on this add clutter height to terrain height, and that will just simply account for the height of the clutter when looking for line of sight. However, this is not the method that gets used in traditional land mobile radio. And so if you're coming from a land mobile type of planning space and want to look at ACARS ground to air type of communications, it would be really important that first we make sure that we're treating the clutter appropriately, because typically in digital mobile radio, you'll use this add clutter loss method, which is just simply going to add additional loss for the clutter type at that location. And my aircraft cruising at 20,000 feet will be unaffected by the trees directly below it, typically. Um, so we don't want to account any kind of clutter loss. Potentially, if we want to, we can include clutter screening for the height if it's sitting along a ridge or something like that. But more importantly, we may want to build additional variability losses onto the model, and we'll want to be pretty strict with those variability losses. Um, and you'll notice in this case, I've used an Anderson 2D propagation model, which is typically the choice, an Anderson 2D or potentially like the TIREM, if we're talking about any sort of governmental aviation project, they will often choose TIREM, which is still a terrain path-based model like the Anderson 2D, but it includes some extra terrain roughness correction factors that may become relevant if you've got rough terrain beneath the path between your site and the aircraft. So if the aircraft is reasonably close to the ground and you expect propagation conditions to be dominated by the terrain surrounding your site, your terrestrial sites, then one of these path-based propagation models is probably most appropriate. If you have something at extremely high elevation, there is an alternate propagation model, this ITUR 528, that we'll talk about that a little bit more, a little further in the presentation. But in general, this ITUR model, the 528 model, is for aeronautical comms, and it is for aeronautical comms in these frequency bands. However, it is not as path sensitive. So, especially if you're looking at situations or use cases that are lower to the terrain and the terrain is more relevant, so especially for any kind of drone use case, commercial drones, then we really want to use a model that's very terrain sensitive. So I would encourage you to use something like a TIREM or an Anderson 2D there. And again, to make sure you're using some additional variability loss, um, especially if we are talking about traditional aviation communications for this ACARS system. At distance, the potential for rain fading and cloud fading grows. So we want to make sure we're including some correction factors for those. Um, okay, jumping back to my slide deck here. Oh, the last thing to say about ACARS is that it's not exclusively VHF. The entire ACARS system also includes HF bands, so even lower than VHF, we get down into HF, which can use skywave propagation and effectively cover the entire globe. Um, Darn, I don't quite remember. It's something like a dozen HF sites, or I think less than 20 HF sites that cover the whole globe using skywave propagation. But much more often, we're interested in the VHF signal. The other piece of the puzzle there is satellite communications. We have GPS confirming the aircraft's position, and then there's also the potential, especially for uh, polar flights and or uh, long distance, intercontinental flights. They will sometimes use, or rather, I should say, often use satellite communications to ping their location information and for voice as well. Uh, Full satellite communications is not yet supported in SignalPro, but that's coming soon, and we'll talk a little bit more about that. Um, And so coming back to drones, this is again quite different from traditional sort of high altitude passenger aviation or military and government aviation planning. There's other frequency bands, other technologies in use. Um, and drones tend to fly much lower to the earth and are therefore much more likely to have their coverage and performance affected by uh, terrain, clutter from buildings and trees, and also noise, RF noise in band. All of these things can, of course, be planned for in Signal Pro as well. Um, and so just to kind of talk about the technology, if we were looking for some reason at consumer models using, our 2.4 gigahertz unlicensed band, either for just your radio controllers for hobbyist drones, or if it uses Wi-Fi, these are most often pretty strictly line of sight operation. And obviously, we could set up and do some studies in Signal Pro for this, but generally, this hobbyist level equipment is there. There's no commercial use case for it. The commercial drones that are starting to see a lot of use in industrial operations, power grid operations, mining operations, all kinds of stuff where you might want to fly a drone around and inspect things or fly a drone around and deliver things. These typically use 4G or 5G cellular. And so ultimately, the coverage planning for where can I guarantee nice, reliable coverage for these drones? What is my usage area? That would be much like uh, doing coverage for a terrestrial project where I might go in and use the Wi-Fi module, set up the specifics of the Wi-Fi technology that I'm using in my drones. Or I'm sorry, if we're talking about commercial, I would want to go into my LTE Pro or my 5G module potentially, set up the band that I'm using. Let's actually go through that. Just for the moment, I will pretend that I've got a 5G drone project here around Denver. I've got a ski resort and I'm gonna use drones to look for skiers who've been buried or whatever. What I would do in here is set up a site template for my 5G band, and I would come in here and maybe set up the configuration, the link budget detail, the frequency, all of that kind of thing. But then crucially, when I set up the template for these sectors, I'm going to choose my 5G system type. And as soon as I choose a system name or type, and that essentially overlays a technology overlay onto this sector. And so then I would go up under network design, 5G networks, and in my technology profiles, this is where I would choose which 5G band or bands. If I've got more than one, I can add them into the list here. And so, oh, who knows? Well, I'm not sure even what bands are relevant. I should have done that research, but I can pick a band here and then see the various different bandwidth and options for that technology under the standard. And once I've defined those and added some sites into my project, I can further go in and under my 5G and sectors here, if once I have some sectors defined as 5G sectors, they'll show up in this list and I can assign one of those frequency bands to them. And so then I would go in and again, in this case, I've set up a received power at remote study. But let's say I need to look at data rate. I want to know deliverable megabits per second up and down from my drone. And this would apply just as equally if we were looking at broadband to aircraft or telemetry of some kind to aircraft, whatever the case may be, we would define the study metric that we want to see. So in this case, I'll go and add study, go into my 5G module, if I can find it with these glasses. And then here I've got the performance criteria for 5G. I've got my RSRP, my RSRQ, and crucially, my throughput on the uplink and the downlink. It would be the exact same process if I'm doing LTE. I would grab my LTE Pro studies and go up under the LTE menu and define my technology, my frequency bands, etc. And then I would run these studies for those LTE sectors. The difference might be that, again, I might run them for multiple different flight levels if I want to see them on an area wide basis. Or again, if I've got drone flight paths through an urban environment or something like that, then I might want to come down here and under route studies, here's where I can go in and set up any of those same study types. So I can come into route studies and set up a 5G system or an LTE system and look at those same metrics. But instead of looking at them in an area-wide uh, heat map sort of method like this. So this is my received power, and I could do the same sort of area study to show data rate for these different flight levels. And you can see if I get down to 3,000 meters here, there are places where we can't actually connect back to either of these towers here. But then if I just get a little bit higher up, now you can see where I do have line of sight. And this is for our ACARS systems or telemetry to test aircraft and things like that. This is typically the sort of planning we would see. But if we wanted to plan a specific flight path, whether for a drone or a test aircraft or what have you, what we can do is define any of those same study types under route studies. And in here for define study route, here's where I can point to a BNA route file. And normally, if I was doing railroad design or looking at communications along a highway or something like that, then the mobile remote unit elevation at each point on the route, I would just choose whatever method I have currently selected for my mobile remote unit. And then if my mobile is at 3,000 meters, then that whole route, it will show to me as though the mobile was at 3,000 meters AMSL. Or if I've got that device tied to the ground, it'll tie it to ground level. However, if we want to do a flight path where our AMSL height is varying over the course of the route, then what we would do is select this use.lev route file. And this file is really, really simple to format. Oh, here I've been sort of talking about these concepts here, so I'll kind of skip this slide. But here's an example of what that BNA route file and the LEV file looks like. This little screen capture here. Um, the EDX polyline This is just named this because I used our draw tool to create this file originally. This can be a name. So you could put in here, route one for if you need to do a whole list of different routes. And then we've got the number of coordinate pairs. So that this is a nice simple little flight plan. We've got six different lat long pairs. And this elevation over here is in meters AMSL. So what we're saying is our aircraft starts out at 3,000 meters AMSL at this location, then proceeds on to this next location, next waypoint of 4,000, up to 5,000, back down to 4,000, 3,500 and so on. And so if I go and look at this route study in the software, here is one that I cooked earlier. Here is my route, and you can see it's the turns are pretty sharp because I used only just 6 waypoints. And that route is going up and down as we go up over the mountains here. It adds some elevation to get over this ridge of mountains, and then it starts to descend again as we get down into Denver. Um, and so in this case, you can see that my if I go back to my area study, the route started out at 3,000 meters here, and way down here, it's showing the same result as my area study for 3,000 meters. We don't have connectivity, but as it starts to ascend up, it picks up that signal earlier than just my area study. So it's in this way, we can plot a complex flight path, including all its variation in heights, and show the performance along that path. And so, for example, if we were looking at drone power line inspection and you needed to plot a path out across some terrain where you've got the power lines going out across these hills, and you need to say, how high up does my drone need to stay as it goes from one tower to the next to go take its videos? Using this route study, you can figure out, will this flight path work, or will I go into an area of no coverage, which, depending on the drone system in question, some of them will fly to their next waypoint no matter what. Some of them will try to fly back to the last place they had connectivity. So, depending on your platform and your needs, consistent connectivity along the path may not be crucial, but you need to have connectivity at least in certain points on the path. So these route studies can really be quite useful in that way. And again, the way that you would develop these is either simply to import those coordinates, latitude, longitudes, and heights, which those can come from the GIS tool of your choice, whatever you're using to plot these paths. Um, or if you're purely just using SignalPro, what you can do is use the draw polyline function here. And I want to make sure it's a polyline so that I don't have to close it back on itself like a polygon. But if I just use this draw polyline, it'll let me, here, I'll choose some empty space. It'll let me click some points to outline a route, as many as I want. And then when I double click that, that gets saved temporarily into my EDX graphic objects layer. And I want to go ahead and just right click on one of these points and save this to a file. And so I could call this file route 2. And now at the moment, this route doesn't have any elevations in it. It's just those locations. If I go and pop that open in, again, the spreadsheet editor of your choice, just open it as a CSV, and you can access those elevations and just go ahead and plug in elevations for each of your waypoints. And then again, once you've got that file, what you do is add a .lev extension onto the end of it so that you have a file that's called, let's say, for example, route.bna, and then route.bna.lev. And then when you go in and define your study route for your route study, you can check that use lev use that .lev route file, and it'll go ahead and update the elevation at each little point along the study path. So it's going to interpolate. It'll make a straight line in between your elevation changes. Um, and so, using those route studies again, you can get much, much more detailed about will this particular path work, including my changes in elevation. Um, and we really welcome feature input and feedback on this. At present, we have a few users that are sort of uh, dipping a toe into doing these drone planning, and they're perfectly able to run the studies they need, and they're getting out the metrics they need from this. Um, However, if we have more of our current users actively doing more and more drone planning, we're well aware that we could do things like bring in a bunch of these routes at once, or make it easier to graphically create these routes, or whatever your pain point might be in this process. Um, Please do reach out to us if you're using SignalPro to do any of these aviation use cases, and there's something that could be a little more slick. This is an area where EDX is focused on maintaining our feature set and maintaining a really relevant, really cutting edge feature set for any of these different use cases, whether they're drones down at low altitude in among the city, or extremely high elevation aircraft getting up into aerospace, which is going now the other direction. So, looking back at my slides here, um, Signal Pro is set up, the architecture of Signal Pro. It is a GIS based platform, and part of that means that we're using a realistically curved Earth, and if you put your antenna extremely high up in the air, including a base station, if you want to, I can go into the software and put quite an absurd uh, height above ground level for my site. We'll accept big numbers in here. There is a max, but you can put a big number in for your site elevation. And we're starting to see a little bit of usage in the aerospace industry, where if we've got LTE communicating with this satellite delivery rocket, then there are regulatory obligations as well as obviously planning needs to say, what is our LTE connectivity going to look like as that rocket goes through its ascent stage and its boost phase, which is essentially going up to a great height and then, turning right and going east really quickly. And so through that ascent phase, you'll get a coverage area of potential interference and also ground stations that are still in line of sight. And in those use cases, obviously the terrain becomes irrelevant very, very quickly when our aircraft goes straight up uh, to above the height of commercial aviation before it's really gone much of any distance uh, laterally or to the east. And in that case, that's where we want to switch to a propagation model that's designed for that. The ITUR 528, I will spare you this morning diving into the various different propagation mechanisms in here, but rather than look at terrain profiles and sort of this terrestrial comms type of link budget, the ITUR 528 is designed to look at the potential for rain fading, cloud fading, decorrelation of the signal, um, ionization. Oh, wait, no, that's the next model. But there's another. Oh, scintillation is the one that's included in the 528. So in other words, upper atmospheric effects and the decorrelation effects that take place in the upper atmosphere are handled by this ITUR 528. And so if your aviation need stops being near the ground and turns into we're going straight up and then going east really fast, really this ITUR 528 is the more appropriate model to choose. And currently, there is a funny limitation on this. The model in its published implementation is a model which assumes that it is the base station. It is the TX that is at an extreme elevation above ground level. So the previous study method that I did, where if we look back at my project, and what I've done is put my terrestrial station here at ground level, and then I've done studies to different flight levels. What we need to do in the case of, well, a rocket is to make the transmitter, the base station itself, the thing that goes up and then changes its location. And the mobile remote unit, or that becomes the terrestrial stations that we're concerned with, whether we can connect or whether we will interfere with them. So in this case, then I would go into my mobile remote unit here, and instead of tethering that mobile remote to AMSL sea level, or height above mean sea level, I'll tie that remote back to the ground level, just like I would for like a land mobile or a typical terrestrial comms. And what I will do is take discrete positions for that base station. So maybe one shot right at the launch pad, one shot a few thousand feet up, and so on. And you'll plug in the lat long as well as its elevation, and you'll need to run that study in sort of snapshots. Um, again, we don't have a lot of users doing this yet, and there is the potential to automate this. So, as you may know, SignalPro has an API that can essentially be used as a way to connect programmatically to the software and set up a script that'll run a repetitive process. So, if we need to move the site and run the study, and move the site and run the study, you can set up a script that'll do that and basically give you an animation of what coverage will look like as your base station, in this case, our effectively our transmitter, goes up in the air and then starts moving, across the map. Um, and so that's kind of the one limitation on our really high altitude communications right now, is that because of the way the published model is written, we're required to treat the transmitter as the thing that's up in the air. We are, as part of a roadmap item, we're looking at whether we can reverse this and make it reciprocal without invalidating any part of the model. But because some of these effects are a little bit different from usual terrestrial radio propagation, we didn't want to just just do it differently than it's published. Uh, with all of that said, I would say if you're on the call today and you're not already one of our users that's doing this aerospace stuff and actively talking to us about it, um, please do reach out. If this is a use case that either you're currently looking at in the software or you might have on your horizon, uh, the software is set up to be able to do this, and we will be expanding support for these kinds of use cases as needed. Um, Finally, my last slide here, coming soon, space. Uh, Given the fact that EDX already has a bit of usage both in governmental aviation comms, experimental aviation comms, that kind of thing. And now within aerospace planning, we have a roadmap item, and we're in development for um, two major feature set additions that would include basically enable satellite communications. So if you need to look at what coverage would look like from a satellite on the ground, sorry, a satellite in orbit, what coverage on the ground would look like from that, or a constellation of satellites in orbit. Um, the two major features that we're implementing are the appropriate ITUR propagation model for Earth to orbit uh, link budgeting, and that'll include low Earth orbit. That'll include geostationary orbit. It'll be the right propagation model for any of these orbital levels. And then also the TLE or two-line element data that's used to describe a satellite's orbital flight path. Uh, it's a standardized format that you can go on to the NASA website and download the information in this two-line element format for any particular satellite or constellations of satellites. And those will effectively be the description of where our base station is or where the transmitter will be. And so we're adding as a module, there will be a satellite module that you will be able to ingest this TLE data and show here's what my coverage would look like back on Earth from those satellites. Here's what it would look like to try and send a signal up to those satellites. Um, Again, using all the appropriate propagation model, because that 528 model essentially extends up to near low Earth orbit, and above that, we should transition to another model. So we're laying the groundwork for all of that, and that'll be coming soon. Again, if satellites play into your use cases or play into your business model and the potential to be able to plan that hand in hand with your terrestrial comms. So the use cases that we're looking at will be in areas where where we can't reach out that well with terrestrial comms because there aren't enough sites or it's extremely rural. Which satellites would provide us the best coverage, or those sorts of questions. How do we make a heterogeneous network out of a combination of space-based assets and terrestrial assets? That's really the use case and the design challenge that we've set our sights on for this satellite module. Is not purely just a satellite tool, but a satellite tool that dovetails in with all of your terrestrial comms planning so that we can look at data rates on ground level from a mixture of assets, both terrestrial and on orbit. Um, So again, if this is something that's relevant for you, please reach out to us through support or through your sales manager, and let's get a customer success session scheduled and talk about exactly what you're doing and how Signal Pro can fit into that, and make sure that the features we're designing today are going to have exactly the feature set, are going to be exactly what you need when we roll those out. Um, that's what I had to show you today. Are there any questions, Rory? I haven't even looked at the question portal. Can you take a look and see if there's anything's come in?
Yeah, I haven't seen anything come in on the question panel as of yet, so
Yeah, and I may have slightly anticipated this. It's possible that folks on the call here today don't really want to talk about their use cases amongst mixed company or ask too specific a question. So if you've got those specific questions in the back of your head, reach out to us. We're happy to schedule another call and get sort of into the nitty-gritty on whatever your use case is.
right.
I guess the very last thing I want to leave you with here is as I'm asking you to go ahead and reach out and contact us if this information is really relevant and you want to talk about your use case. Really, any of these contact methods is just fine. Reach out to us at support or through the support portal. Reach out to your sales manager. Give us a call, whatever works, and we'd be really excited to talk to you about what we have in the software to support you right now today, as well as what's coming on the horizon. That's really exciting for some of these new mixed telecoms solutions.
Excellent. Well, we appreciate everybody's time today on the call. So thanks again. Watch our newsletter for the next webinar that we'll be putting on, and there will be a registration link there again. But yeah, thanks everyone for joining.
Yeah, have a good day, everyone.